My Hero Academia does a lot of things well, but scientific accuracy isn't exactly its strong suit. Today, we'll be focusing on one offender in particular, Ochako Uraraka, and her quirk, Zero Gravity. While this perhaps underutilized ability makes for some great moments, it does tend to break the laws of physics just a teeny tiny bit if taken at face value. So, in this video, we'll dive into the actual physics of zero gravity and see if we can't find a way for Uraraka to keep her awesome abilities without entirely disregarding the underlying mathematics. Gravity. We often take this fundamental force for granted, but it's pretty much the only thing standing between us and a very long, very cold journey into the depths of outer space. Without it, there would be no Earth, no life, and no anime. It's one of the most overlooked aspects of daily life, but not so for UA High School's Ochako Uraraka. Ochako's quirk, named Zero Gravity, is presented as giving her the ability to disable the effect of gravity on anything she touches with the pads of her fingers. We see a variety of creative uses in combat, from levitating massive rocks in her battle with Katsuki, to catching a falling Deku in midair. So, what's the problem? Well, to understand that, we first have to take a very brief detour to cover the basics of how gravity actually works, or at least how it works in our daily lives. Most of us have an intuitive sense of gravity as an ever-present force pulling down on things at all times. But that's not really the full picture. Fundamentally, gravity is a force of attraction, and necessarily a vector quantity. If you're not familiar already with vectors, I highly recommend you check out my video about a certain magical index's accelerator. Then, come back here as this video will assume a basic understanding of vectors. For simplicity, let's consider two objects with masses m1 and m2. The force of gravity on each of these objects essentially depends on a few factors. They are the masses of both objects, the square of the distance between them, and the direction of each point from the other. This quantity is then scaled by a certain number, a gravitational constant specific to our universe. All of this is to say each object is pulled in the direction of the other by a certain amount. It's important to note that these forces have the same size or magnitude. The only real difference here is that they point in different directions for each object. Extending this picture to a larger group of objects, where each one affects and is affected by every other, we can see how fundamental objects in our universe, such as planets, come to form from floating space stuff. And additionally, why they're roughly spherical. So, what happens when we introduce a new object to our scene, or in our case, a human to a huge planet? We see that it falls towards the center of mass of the planet. If you're wondering why it seems like the small object appears to be drawn to the big one, even though we calculated that they should have the same force acting on them, we can take a quick look at Newton's second law. Often written as F equals ma, it's pretty much the relationship between the force acting on an object and the object's mass and acceleration. We said F is the same for both objects, but to go from the equation of the small one to the large one, there will be a significant increase in mass. In order to compensate for this, we need to decrease the acceleration accordingly. In our example, this basically translates to a small mass experiencing a much greater acceleration than a larger mass. In other words, as you are drawn to Earth, the Earth is also drawn to you. At a glance, it looks like the Earth doesn't move since the differences in mass are so great. So, with that out of the way, let's take a look at what would happen if we suddenly turn off the gravity holding these objects together. No floating off into space or even up off the ground. In fact, nothing seems to be happening at all. How could that be if there's no force acting to keep everything together anymore? Well, while that may be true, there's also no force acting to push them apart, or do anything really. To understand this better, we consult Newton's first law, which some of you may recognize by its alternative name, the law of inertia. Essentially, it says that unless an object is acted upon by some force, it will continue doing whatever it's doing. What that means is, if we throw a hot dog into a perfect vacuum, it will remain going as fast as we threw it, forever, since there's nothing to slow it down. By that same token, if something is standing still and we don't touch it or apply any force of any kind to it, it's going to remain standing still. In our example, since the object wasn't moving, it doesn't suddenly start moving when we turn the forces off, or in other words, set gravity to zero, as Uraraka does. Finally, we can return to Ochako and see the issue here. If we suddenly turn off the gravity of a tank, unfortunately it's not going to suddenly start floating up into the air, and nor would an arena full of rocks. Moreover, if we have a wild Deku falling from the sky and we turn off his gravity, he'll stop accelerating towards the ground, sure, but Newton's first law tells us he's going to keep travelling with the same velocity he had, and, barring some minor slowdown from air resistance, become a green-haired splatter on the ground. Okay, so while there are some issues here, I'm not trying to ruin any of the cool moments that we have with Ochako. That's why I want to talk just a little bit about how we can make a tiny adjustment to her power that makes all of this possible. Let's revisit the gravity equation from earlier. I mentioned briefly that our entire gravitational force is scaled by the gravitational constant. which is really just a specific number. If, rather than setting the force of gravity equal to 0, we instead conceptualized her quirk as the ability to adjust this gravitational constant, the realms of possibility open back up. Adjusting this number, she could make it negative, causing things to be pushed up and away from the Earth. Increase it to accelerate things back down at tremendous speed, or just adjust it on the fly to bring things to a hovering stop in midair. By adjusting the quirk this way, we can not only preserve Ochako Uraraka's ability to create all the fun moments that make her one of our favourite characters, but also frame it rigorously inside the context of the mathematics that govern our universe. If you enjoyed the video and want to see more content like this, make sure to subscribe and feel free to check out the links in the description. Let me know in the comments what you think of Ochako's new quirk and if you have any other suggestions.